Hello everyone, I hope you are doing well. So in today's video, we'll be going through the 2022 physics exam multiple choice section. Like always guys, before I start this video, if you guys want private tutoring in specialist methods, physics or chemistry, you can always email me through this email. And yeah guys, let's smash through this video. Question 1. A single loop of wire carries a current I as shown in the diagram below. Which of the following best describes the direction of the magnetic field at the center of the circle C, which is produced by the current carrying wire? Yeah, just use your right hand grip rule. So you know how the current is in terms of this, the up, it's turning to the right. So, use a right hand grip rule and make sure your thumb's to the right, and you would see that your hands are curling this way. So you would see that this part here will be coming out. This will be coming out and this will be coming in. And you can do it throughout the thing. So if the current's also going to be down here, again, try to do that. So we can see also that current is also always in and this is out. So throughout the whole thing, it's all actually in. The magnetic field is always in to the page. And so the question says, which of the following best describes the direction of the magnetic field at the center? Because all at the center, they're into the page, C must be into the page. Nice and easy. And whereas outside will be out of the page. Nice and easy, just use your right hand grip rule there. Question 2, let's have a look at this. The diagram below shows the magnetic flux variation for a coil of an AC generator. Which of the following best is the closest to the frequency of the magnetic flux variation for the coil of the AC generator? The frequency. So we're actually given the time. And remember, frequency is just 1 over t, which is t is the period. Well, the period is what? For example, just pick a full function, like a full cycle. So for example, here, or full cycle here. So that's 0 to 0 0.04. That is one period. So that's going to be 0 0.04. Just one full cycle, and that's going to give you a frequency. Easy. And that gives me 25 hertz. Easy answer. Question 3. Particles emitted from a radioactive source travel through a magnetic field B, directed into the page as shown schematically in the diagram below. 3 particles K, L, M, N follow the path indicated by these arrows, alright? Which of the following correctly identifies the charges on particle K, L, and M? Actually, this question, I've seen it in one of those, I think it was a VCE chemistry exam. Units 1 and 2, I've done that, and I saw one of these kind of similar questions. So you should know that if a particle doesn't actually get affected, so it doesn't turn, but just keeps going straight, it's unaffected because it does not have a charge. There's no force created, so it doesn't have a charge. So L must be a no charge, which looks like B is wrong because it says it's negative. Well, okay. So let's say that K, let's choose this one. Let's say that K is positive. So if K is positive, what do we know? So we're going to use our right hand step rule. And so always, if we're considering it's positive, we're going to use our right hand. If it was negative, we would consider our left hand. But in this case, we're considering K as to be, the charge to be positive. So imagine you're using, your right hand slap rule. And what you're doing is, of course, the velocity is going to the right. So you make sure your thumb is to the right. And also your fingers are directed into the page, because remember, that's your magnetic field lines that are into the page. And hence, where is your palm? Your palm is upwards. So actually, the one that goes upwards, in this case, K, is the positive one. So these are all wrong because they're saying negative, no charge. A is right. And M, of course, is negative because it goes to the opposite. And you can actually check it by using your left hand. So again, make sure your thumb is to the right and your fingers are into the page, and you would see your palm going downwards, where M is going downwards. Nice. Question 4. 2-point charges Q and 4Q are placed 12 centimeters apart, as shown in the diagram below. Okay, so they both have the same charge, but one has 4 times the magnitude. On the straight line between the charges Q and 4Q, the electrical field is non-zero everywhere, 0 at a point 2.4 centimeters from Q, 0 at a point 3 centimeters from Q, or 0 at a point 4 centimeters from Q. So I know for a fact, because they have the same charge, they're going to be repelling. But because this one has a stronger magnitude, it would be looking like this. So this will have like a small repulsion, whereas this one will take that most of that space because it's very much strong. And as we can see, we would have this point over here approximately that will have a 0 electrical field. So we know that it's less than 0, like it's between here. It's, yeah. So A is wrong, by the way, because it's a non-zero everywhere. No, there is at some places that there are magnetic field. There is an electrical field, sorry. Let's see how we can determine the distance from Q where it's 0. So if I rub these out and just keep this, I know this here, we said that the electrical field is at 0. If I actually say that the distance from Q to this is X, and that's what we want to calculate, yeah? This is our X, that's the distance from Q. And we'll consider this distance from here to here as Y. And so let's just consider this over here, this case, the X. So we know electrical field is actually just KQ, which in this case, our charge Q, R squared, which in our radius is X squared. And we know that the electrical field is 0 in that, in this part over here, as we said. And so let's also consider this one over here. So doing the same thing, electrical field is 0 at that point, K, but our Q is 4Q, so it's going to actually be 4KQ Y squared. And because, they both have the electrical field that is at 0 at the same point, we can actually equate these two. KQ X squared is equal to 4KQ Y squared. And we can actually cancel those KQs out, and we're left with 1 over X squared is equal to 4Y squared. And if we cross multiply them, so if Y squared equals 4X squared, and take the square root of both sides, we'll get Y is equal to 2X. So we can know that Y is equal to 2X. So we can actually replace this Y with 2X. So pretty much the distance from here to here is actually just 3X. So, and we know that 3X is just equal to 12 centimeters. Hence, X is just 4 centimeters. So meaning that, let's rub all this out. Remember how X was this distance from here to that value, where it's at electrical field is 0? That's our X, which is 4 centimeters. And so it's 0 at 0.4 centimeters from Q. D is your answer. That was a lot of algebra to be honest, but yeah. Question 5. A simple electricity generator is shown in the diagram below. When the coil is rotated, the output voltage across the slip ring is measured. The graph shows how the output voltage varies with time. Okay, we're given that. The frequency of the rotation of the generator is now doubled. Which of the following graphs best represents the output voltage measured across the slip rings? So we know that the frequency is doubled. We know that period is just 1 over the frequency. And if you double that frequency, we halve that period. The period will actually halve. And remember, the period is the time it takes for a full rotation. So you know how the period in this case for one full rotation is 0.1? We halve it. So now it will be here. So for one full rotation, it will be over here. It will end like this. This is for one full rotation. And yeah, so we'll have 2 pretty much. In other words, it will have 2 rotations because we've halved the period. Which one looks like that? Yep, B looks good. Also, C looks good. These ones are wrong. The A and D, as you can see, for one full cycle, it's at 0.1. And it would, yeah, that's wrong. It would have halved. And also this one too. One full cycle is at 0.1. But let's also look at the amplitude. How does the amplitude get affected? Well, the amplitude is the voltage. So we know that EMF is equal to, negative N, change in flux over change in time. And we know that this change in time is your period. So if we halve that period, so imagine T over 2, we halve that period, we've actually doubled the EMF. So we've doubled the, we've doubled the amplitude. So this, in this case, this graph will look like, so it would still have that, but it would look like this. Oops, what am I doing? Like that. Like that. It would be, double the amplitude. Which looks like C is your answer. Done. Question 6 and 7. Let's have a look at this. All right. A railway track X of mass 10 tons moves at 3 meters per second, collides with a stationary railway track Y as shown in the diagram. After the collision, they are joined together and move off at a speed of 2 meters per second. All right. Which of the following is closest to the mass of the railway track Y? Easy. So let's consider this as M1, U1, well, the initial velocity, and this as M2, U2. When in this case, U2 is 0, but yeah. And this here we'll consider, because they're both joined, it's going to be M1 plus M2, that's their masses, and also their velocity is, your final velocity is 2. So equating all these, because remember it's the conservation of momentum, we know that M1 times U1 plus M2 times U2 is equal to M1 plus M2 times V, which, V final. So M1 in this case, make sure it's in tons because we don't have to convert them into kilograms because all of them are in tons. Your answers are in tons, so just can leave them with tons. So 10 times U1, which is 3, plus M, which is, we don't have an idea what M2 is, and that's what we're trying to calculate, times U2, which is 0 because it's stationary, so that just becomes 0. Is equal to M1, again, it's 10, plus M2 is what we're trying to calculate, times V, which is your final velocity, which is 2. Well, so what's 10 times 30? That'll be 30. And so that'll be 20 plus 2m2. So it'll be 10 is equal to 2m2. And m2 is actually equal to 5 tons, which is B. Question 7. Which of the following best describes the force exerted by the railway truck X on the railway truck Y, Fx on Y, and the force exerted by the railway truck Y on the railway truck X, Fy on X at the instant of the collision? This is the application of Newton's third law, because what they're saying is, so when they collide, there's going to be a force, of course, force on Y by X, which in this case is, so which one's it? They read it in the other way, so force by X on Y in this case, you can write it, which is this over here, force X on Y, which is that force. And remember, by Newton's third law, there's going to be an opposite reaction force, but in the opposite direction, but has the same magnitude force, which is F by Y on X. Let's have a look at the, and that's that one. So let's look at the Fx on Y is less than, no. So they have the same magnitude. So A and D are wrong. So there has to be an equal sign. Yep. C is the most correct. And here's why. They have actually put a negative. Because remember, the other force is going to be in the opposite direction. Yeah. Easy. That is an application of Newton's third law. Beautiful. Question 8. The graph below shows the force versus compression for a spring used in physics investigation. Okay. Which of the following is closest to the compression required to store 0.9 joules of potential energy in the spring? So we know that SPE, spring potential energy, is actually just half K times change in X squared. And we know that if we know that the spring potential energy is 0.9, so half, what's our K value? Our K value can actually be determined from the graph because it's just the gradient of this graph over here, which will be, this here is 0, 0. This here is 40, 0.08, 40. Hence your K value is just 40 minus 0 over 0.08 minus 0, which is 40, 0.08, 500. So K value is 500 times change in X squared. And we're trying to calculate change in X squared. So what's that going to be? So 0.9. So 0.9. 50. Take the square root of that. That gives me 0.06 as your change in X. Easy. Question 9. Two students pull on the opposite ends of a rope as shown in the diagram below. Each student pulls with a force of 400 newtons. Alright, so this guy is pulling up for 400 newtons. And this girl is pulling up with 400 newtons. So both are equally pushing 400 newtons. Which of the following is closest to the magnitude of the force on the rope on each student? So again, this is just an application of, Newton's third law. It's going to be the same, equal magnitude, but in the opposite direction. So isn't it just going to be 400? Yeah. Because remember this here, this force over here is the force, so F on rope by, so student. And so it's going to be equal to negative F on student by rope. And this over here is what this is telling us what the magnitude is it. This here, the force on rope, so force off the rope, yep, by the rope, on each student, so on the student. Yes, they're going to be in equal magnitude, so 400 newtons. And we're talking about magnitude, so we don't have to worry about the direction, negative, 400, just 400. Question 10. Which of the following statements best describes an observation of the Doppler's effect for sound? Okay, a decrease in frequency received when a source of sound moves towards you. So when a source of sound moves towards you, the frequency is actually going to be increasing. Wrong. B. A decrease in frequency received when moving towards a stationary source of sound. So imagine like something's making sound and it's stationary and you're moving towards it. The frequencies the frequencies are going to actually increase. That's also wrong. C. An increase in frequency received when moving towards a stationary source of sound. Beautiful. When you have something stationary and it's making like sound like a siren and you go towards it, that frequency is going to increase. Your frequency that you receive is going to increase. So C looks great. Let's also look at D. A decrease in wavelength. So make sure it's in frequency. So you remember wavelength is proportional to frequency. So inversely proportional. My apologies. So if there's a decrease in wavelength, it means it has a high frequency. So what we're saying is like an increase in frequency received when moving away from a stationary source of sound. So if we're moving away from a stationary sound, the frequency is going to be decreasing. So that's also wrong. So C is right. Let's have a look at the next question. Question 11 now. Which of the following statements best describes transverse waves and longitudinal waves? Both transverse waves and longitudinal waves travel in the direction parallel to the vibration. Rubbish. Remember, longitudinal waves only are in the direction parallel, whereas transverse waves are perpendicular to their vibrations. That's wrong. B. Both transverse waves and longitudinal waves travel in the direction perpendicular. Rubbish. Again, only transverse waves do that. C. Transverse waves travel in the direction perpendicular to their vibration. Beautiful, yes. And longitudinal waves travel parallel to their vibration. Absolutely beautiful. Let's also look at D. Transverse waves travel in a direction parallel to their vibration. Nope, it's just the opposite. So C is the right one. Question 12. A 45-degree glass prism is submerged in water and oriented as shown in the diagram below. It is used to reflect light ray through 90 degrees. Okay. What is the lowest refractive index of the glass prism that will ensure that total internal reflection occurs inside that prism? So what's happening is, okay, they put light, and so remember this is your interface. So remember this is your normal. So always this is your normal right over here. So draw it nicely. So this is your normal right over here. And so as we can see, this is the actual light. So let me use a different color. This is your incident. This is your incident ray. And it's going, so this is your incident ray. And of course, like, it's because it's gone through total internal reflection, it's not going to be, in here. It's going to be, we know it's internal reflection, so that's why it's still inside that glass prism. But what the question is asking us, what is the lowest refractive index of the glass prism that will ensure that total internal reflection occurs? So what is the lowest? So the lowest is actually where the critical angle will happen. So here, this is where the lowest, because this is what they're asking us. What is the lowest? So that's where the critical angle is going to happen. And so to find that, you remember your critical angle formula. It's just N1 sine theta C is equal to N2. Because we're going from N1. N1 in this case is the glass prism, which, are we trying to find that? Yeah, so N1 is what we're trying to find. Sine, what's the angle? You remember the angle, it's this. This is your critical angle. And it's actually just 45 because we know this is here is a right angle triangle. Halfway, it's 45 degrees. So 45 degrees. And N2 is the water, which is 1.33. So it's just going to be 1.33 sine 45, which is 1.88, which looks like D is your answer. Nice. Question 13. A traveling wave produced at point A is reflected at point B to produce a standing wave on a rope, as represented by the diagram. Okay. The distance between the points A and B is 2.4, so this distance... Oop, what did I do there? Is 2.4 meters. The period of the vibration of the standing wave is 1.6. So we know the period is 1.6. The speed of the traveling wave along the rope is closest to what? So if we want the speed, it's just the wavelength times the frequency. What's our wavelength? Remember the wavelength is... So wavelength is just this over here. We can consider this as one wavelength. Remember, it's just like a cycle. And so this is your wavelength. It's just pretty much half of 2.4, which is 1.2, yeah? So 2.4 divided by 2 is just 1.2, yeah. So we know that velocity is 1.2 times, what's your frequency? Remember, frequency is just 1 over t, the period, which is actually 1 over this, 1 over 6. So putting 1 over 1.6, that here should give us our velocity. 1 times 1 over 1.6. That gives me 0.75 meters per second, so A. Beautiful. Question 14. Which of the form best provides evidence of electrons behaving as waves? One of the actual best ways, is like one of the best explanations is that electrons behave as waves, like a proof, is the diffraction patterns. Yeah, through crystals. So whenever you see that is electrons behaving as waves. Because remember, diffraction is a wave property. And if electrons, like particles, electrons are actually, creating a diffraction pattern, that tells us that they act as both waves. So 14. A photoelectrical effect? No, photoelectrical effect actually proves that it is a particle, so not that one. B. Atomic emission spectra? I don't know what the hell that does, but no. C. Atomic absorption spectra? Nope. Diffraction of electrons through a crystal? Yes. Diffraction is a wave property, and, yes, that's absolutely proof that electrons behave as waves. The best evidence in this case. 15. Which of the following best provides evidence of light behaving as particle? Yes, so this is just, the photoelectrical effect. That is the best explanation. When light passes through a prism, that's proving it's a wave, because that's dispersion, isn't it? Yeah. That's not right. So that's telling us it's a wave. Diffraction of light through a single slit. Again, that's providing us that it's a wave. It's not providing evidence that it's a particle. Interference of light passing through a double slit. Again, that's rubbish. So A is the best proof for a photoelectrical effect that proves that light can also behave as a particle. 16. Which of the following phenomena best demonstrates that light waves are transverse? Polarization? Yes! Polarization only occurs for transverse waves. Always remember, polarization only for transverse waves. So the best phenomena that shows that light is a transverse wave is probably polarization from all of these. I'll put a tick on that. Let's have a look at that. Interference. Interference can pretty much be for anything, like both transverse and longitudinal. So nope, not that. That's fair. It doesn't really prove that it's a transverse wave. It's not the best way to depict it's a transverse wave. Dispersion, also not true. That doesn't... Diffraction. Yeah, that's not... So the best way to show a transverse wave is through polarization. Because remember, polarization, I think that all the other ones both go for transverse and longitudinal. But remember, polarization only works for transverse waves. And that's the best one to depict if it's a transverse wave. 17. Gamma radiation is often used to treat cancerous tumors. The energy of a gamma photon emitted by radioactive cobalt-60 is 1.33 mega electrovolts. Which of the following is closest to the frequency of the gamma radiation? So 1.33 times 10 to the power 6 electrovolts. Remember, we want to convert this to actual joules, and to do that is we just multiply it by 1.6 times 10 to the negative 19. That's going to give us what? We also want to make sure it's always in joules. Makes our life much more easier. That times 1.6 times 10 to the negative 19, and that gives me 2.128 times 10 to the power of negative 13 joules. And so the formula that comes, where's the formula sheet? So we have now the energy, and we want to find the frequency. So, there's the formula. Energy is just H times your frequency. So if we want our frequency, it's just the energy, which in this case is 2.128 times 10 to the negative 13 divided by the your Planck's constant, which is 6.63 times 10 to the negative 34. Let's put that there. To the negative 34. And that gives me 3.2 times 10 to the negative... So 3.2 times 10 to the power of 20. Which looks like B is your answer. Last 3 questions. Wow. I just want to get this exam done. Which of the following is an example of inertial frame of reference? Remember, inertial frame of reference means non-accelerating frame of reference. Let's have a look. A bus traveling at a constant speed. Beautiful. Constant speed is non-accelerating. So that could be right. An express train that is accelerating. Wrong. We don't want acceleration. A car turning a corner at a constant speed. A lot of students don't know this, but okay, they think that, seeing constant speed, they think it's the same as constant velocity. Wrong. Because it's turning a corner, the actual direction is changing. Hence, remember, if direction is changing and velocity, includes both magnitude and direction, if, velocity is changing, also there is going to be acceleration. So that's wrong. D, a roller coaster spinning up while heading up down a slope. Again, this is accelerating. Only A is the best. Question 19. A particle produced in a linear particle accelerator is traveling at a speed of this. Take the speed of light to be this. Which of the following is closest to the Lorentz factor? Wow, what a beautiful question. So Lorentz factor, of course, is 1 over. Is that? Yep. So 1 over square root. So square root, okay, let me put that, yep, 1 minus. So the velocity, which is 2.99 times 10 to the power of 8 squared. And the speed of light, which is 3.0 times 10 to the power of 8 squared. Putting this in your formula should give you your Lorentz factor. Which gives me 12.25. 12.25, which is approximately C. Yep, that was good. Question 20. The experimental uncertainty of a measurement is best understood as what? An estimate of the validity of data. So when we're talking about validity, is this experiment valid? So does it answer the aim? Does it, follow the method and all that stuff? Really, that doesn't... What the hell does that got to do with uncertainty? So that's wrong. B, a mistake in the experimental method used. No, that's not what uncertainty means. Not a mistake. A mistake in the recordings of measurement. Nope. An estimate of the maximum likely difference between the measurement and the true value. Beautiful. That's actually one of the best definitions. So it's just like an estimate where the true value lies between. That's what uncertainty is. So D seems like the perfect answer for that. And yeah, that's it. I hope you guys enjoyed this video and learned something through it. Please make sure to like and subscribe to this channel, and please share it with your friends. I hope you guys enjoyed this video and have a great day, guys. Bye-bye.